Hello everyone, welcome to today's class. In our last video, we did uh, addition and subtraction of numbers in different bases. So today, we are going to look at multiplication of numbers in different bases. So long as you have learned how to add a number basis, multiplication is not going to be a problem, just like in base 10. You know that in the last time, we always use base 10 as a yardstick. Then we now move to other bases. How do we multiply numbers in base 10? The same way. We have 2, 3 times 1, 9. Let us multiply this number in base 10. 9 times 3, that will give you what? 27. And what do we do? In that 27, you separate this 27 in tens. That will give you 10 plus 10 plus 7. How many 10 do we have? 2. You can see where the 2 is coming from. 2. What do we write? 7. 9 times 3, 9 times 2, 18. 18 plus 2, 20. So we also share 10 plus 10 plus 0. How many 10 do we have? 2. What do we have? 0. So there's nothing to multiply, so you bring down your 2. You do the same thing. 1 times 3, 3. 1 times 2, 2. You now add and add your numbers 7, 3, 4. You have your answer. The same way, okay? The same way. And another thing I want to show you, some students don't know how to multiply numbers in decimal places, okay? Let's take, for example, 2.1 times 1.23, something like this. It becomes a problem, but there's easy way of doing this. Very simple. Multiply your numbers times 1.23. This one is not up to, so how many decimal places do we have here? We have 1 decimal place. How many decimal places do we have here? We have 2 decimal places. Remove it and multiply your numbers. As simple as that. Okay? Remove it and multiply your numbers. 3 times 1, 3. 3 times 2, 6. 2 times 1, 2. 2 times 2, 4. 1 times 1, 1. 1 times 2, 2. Add your numbers. 3, 9, 5, 2. Please, first number have how many decimal places? 1. Second number have how many decimal places? 2. Our answer is going to have how many decimal places? You add the decimal places. 3. 1, 2, 3. I'll put my decimal points. That's how to add numbers in decimal places. So I can put back my point. So this is my answer. Okay. So we are going to apply all this knowledge that I have shown you now in multiplication of numbers in different bases. So let's start with the first example. So our first example is number in base 2. Of course, that's the easiest number to multiply in number base. So we take our number 1 times 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1. So you add. So when you add, this is where you have to be careful. Remember what we did in addition. So 1, 1, 1 plus 1, that will give you 2. 2, you share it, 2 plus 0. So you have what? 0. How many 2 do you have? 1. You add it here. You add it on this one. So 1 plus 1, 2 plus 1, 3. You also share your 3. So that'll give you 2 plus 1. You take your 1 and write what? 1. 1 plus 1, 2. You write what? 0 and take 1. You bring down your 1. So I was fast on that one because it's something that is very simple and something that we have done. Okay. So let us look at other bases and see how whether it's going to be as simple as this or a little bit more difficult. Find out. So we have 121 base 3 all square. What's the meaning of all square? If I have 2 square, what does that mean? 2 times 2. So they're asking us to multiply this thing by itself. So that will give you 121 base 3 times another 121 base 3. So let us multiply our numbers. Okay, so we have to be a little bit more careful here. 1 times 1, that will give you 1. 1 times 2, that will give you 2. 1 times 1, that will give you 1. So come here, 2 times 1, that will give you 2. 2 times 2, that will give you 4. Share your 4 in base 3. So that will give you 3 plus 1. How many 3? 1. Then you now write your 1. So 2 times 1, 2 plus 1, that will give you 3. 3, share it in 3s, you have 3 plus 0. So how many 1? You write your 0. So you bring down your 1. So you now come to the next one. 1 times 1, that will give you 1. 1 times 2, that will give you 2. 1 times 1, that will give you 1. So you add your numbers. This will give you 1. 2 plus 2, 4. We have done something like that. So that's 1, 3. You have that 1, 3 here. Then 1. You write your 1. Okay. So 1 plus 1 plus 1 plus 1, that will give you 4. The same thing, we have done that. So you write your 1 and carry your 1. 1 plus 3, 3. So that will give you 0. You take your 1. 1 plus 1 plus 1, 3. That will give you another 0. You take your 1. Okay. So this is what we, this is base 3. This is what we have as our answer. Okay. So you can as well look at it and be sure that what we have here is actually correct. So let's move to the third example now. We have 3, 4, 6 in base 8 times 5, 0 in base 8. Please, I just remember something now. So long as that number is not base 10, please don't call it the way you call numbers in base 10. Somebody will call this one 50 in base 8. Please, we don't have that. If it is not in base 10, you call them by digit. 50 base 8. Because we don't have 50 in base 10, in base 8. We don't have 121 in base 3 in base 3. No, this is 121 base 3. Okay, all those 10, 11, 12, 13, 18, 22, 255, they are all in base 10. So you don't even need to tell me it's in base 10. Immediately you say 522, I know it's in base 10. But when you say 521, I'm not sure which base you are talking about, because you have to let me know the base. Okay. So in this case, I have said that. So we have to multiply. So the same way we have been multiplying, that's the same way we are going to do this. So 0 times 6, that will give you 0, 0, 0. 5 times 6, that will give you 30. Okay. So 30, how many 8 will you get in 30? Let's share it. So that will give you 8 plus 8 plus 8 plus, that's 6. Okay. So 3 8 and what? 1 6. So that will give you, you write your 6, you now carry your what? 3, because we have 3 8. So 5 times 4, that will give you 20. How many 8? 2 8 plus 4. Oh, we are yet to add this. So 23. So plus 7. So you write your 7 and take your 2. 5 times 3, that will give you 15. 15 plus 2, that will give you 17. You share it in 8, that will give you 8 plus 8 plus 1. So write 1 and we'll take how many? 2. So you bring down your 2. So you add. This one is very simple. 6, 7, 1, and 2 in base 8. So that's how to do that. So before we move to division, let us look at one more multiplication, one more example. That example is going to have a decimal number. Okay, so numbers that is in fraction multiplied by a number that is another fraction. So let us see what we are going to do there. Our fourth example, we have a number in base 4, but this number is a fractional number. Remember what I told you at the beginning of this video? You multiply your number, ignore the decimal point, multiply your number, your answer, you just count the number of decimal points, add another decimal point to it, and look for where to put your decimal point. It's as simple as that. So I'm going to ignore the points, okay, and multiply my numbers. When I'm done, I'll put my decimal points. Okay, so let us multiply. 2 times 2, that will give us 4. That will give you 4 plus 0. So we write what? 0. And take 1 4. So add that 1 4 here. 2 times 3, that will give us 6. 6 plus the one that we put here, that will give us 7. So 7 will give us 4 plus 3. We take 1 4, we put it here, then we write our 3. 2 times 1, 2 plus 1, 3. 2 times 2, 4. The same thing happened here, 0. We take 1, we put it down. So we are done with the first digit. Let's go to the second. Second digit will give us 0 because 0 multiplied by everything will give you 0. So 0 here, 0, 0 here, 0, 0 there, 0, 0 there, 0. Okay. Then the next one is 1. So 1 multiplied by anything will give you back the same thing. So 1 times 2, 2, 3, 1, and 2. So we add. So this is going to give us 0 here, 3 here, 5. So share 5 in 4. That will give you 1, 4, and 1 remaining. So write 1. 1 plus 3, that will give you 4. So that will give you 0. You take 1 and add here. 1 plus 1 plus 1, that will give you 3. And you now have what? 2. Okay, so we have our numbers, but the points are not there yet. So 2 decimal places plus another 2 decimal places, that will give you 4 decimal places. So 1, 2, 3, 4, that will give us 23.0130 in base 4. As simple as that. So this is where we are going to end multiplication of numbers in different bases. So let's move to division. Division in number base can sometimes be complicating. I say something like that in when we are doing multiplication. There are many ways you can do this thing, but I'm going to major on 2 ways you can solve problem on division. One method is very simple, shorter. Oh, let me not use the word simple. It's very short. It's actually short. That's making use of long division, but it's a little bit complicated. In base 2, you might not really see how complicated it is until you do it in different numbers in base 16, base 8, base 5, especially the ones that will give you a decimal number. What I mean by the ones that will give you a decimal number, the one that will, when you just like when you have 5 divided by, let's say 4. Of course, this will give you a decimal number. So it might give you a little bit problems. So what I'm trying to say is that this method of using long division is shorter but a little bit complicated. Then the other method is long, but it is actually simpler to do. I enjoy doing that because when I do that, when I use that method, it's long, quite all right, but it gives me the confidence that yes, I'm sure that my answer is correct. Okay, so I'm going to solve this problem using the 2 methods. Okay, but please don't judge them by this base. Okay, because base 2, division in base 2 is quite simple compared to division in other bases. So let us do the 2 methods. Like I said before, we're going to do the 2 methods in the 2 examples that I'm going to solve under division. Let's take the first method that I'm using long division now. So that will give us 1, 1, 0, 1, 0, 0, 1, then dividing by 1, 0, 1. Okay. Now, what we do in base 2 is to compare the number of digits, which one is bigger. We don't, anytime a base 2 divide by another number, if that number is quite bigger than the denominator, it's going to give you 1. It's definitely going to give you 1 because base 2 cannot give you any other number except 1 and 0. You can see the reason why I say that base 2, this method, you might not feel how complicated the method is. Okay, because whenever you divide in base 2, you either have 1 or 0. So that's the only 2 things that you're going to have. Now, I will look at the 3 digits here and compare it with 3 digits here. So 3 digits here and 3 digits here, which one is bigger? This side is bigger than the 3 digits here. So these 3 digits, when you divide, you are definitely going to get 1. That's what I was saying. Okay. So 1 times this, that will give you 101. You subtract, that will give you, you borrow here 2, 2 minus 1, 1. That's all. So you bring down 1. Can it go? No. When you bring down one digit, it cannot go. So you add 0 and bring down another digit. So you are bringing 2 down now. But before, you know that when you are doing long division, when you bring down one digit and it cannot go with your divisor, you add 0 and bring down the second one. So when you bring down the second one now, so these two out here, so I have this one, only this one left. Okay, so how many are we going to still have? We are still going to have 1 times this, 1. Oh, 1 time. Okay, that'll give us 101. You subtract again, that'll give you 1. So you now bring down the 2 remaining. So these 2 are done here. So you bring down the 2 remaining, because when you bring down this one, it cannot go. So you add 0, then you bring down this second one, you have 1. So 1 divided by this, that'll give you 1. 1 times this, that'll give you 101. When you subtract, you have what? 0. So we are done. So our answer will give us 10101 in base 2. Remember, this is our first method. Now, what is our second method? Second method is something that anybody can do. So long as you have been with us on this particular topic, everybody, you can actually do it. What is that second method? Convert this one to base 10, convert this one to base 10, carry out your division, convert back to base 2. Yes, I know that you are saying, that's long, but you are sure of your answer, especially if it's in other base, in base 2, you might not really feel that way, that is hard. But when you're doing it in base 16, in fact, there are kind of numbers that even when I'm solving, I have to check and be sure that my answer is correct when I'm doing this method. But when I'm doing the other method, yes, it takes me quite a while to get my answer, but I'm sure that my answer is going to be correct. So let us do the second method. This is our first method. Let's do our second method. Second method is to convert this number to base 10. So I'll put my index. So since I have done this quite a long time, I can easily do it in a shorter way. So that is 1 times 2 raised power 6 plus 1 times 2 raised power 5 plus, this one is 0. I don't need to do that. Plus 1 times 2 raised power 3. This one is 0. I don't need to do it. This one is 0. I don't need to do it. This one is 1. So plus 1 times 2 raised power 0. So that will give me 2 into 6. That will give me 64. I think so. Let's find out. 2 times 2, 4. Times 2, 6. Times, let's go again. 2 times 2, 4. Times 2, 8. Times 2, 16. Times 2, 32. Times 2, 64. So this one will give us plus 32. This one will give us plus 8. And this one will give us plus 1. So 32 plus 64 plus 32, that will give us 96. 96 plus 8, that will give us 104. Yes, plus 1, 105. So we have gotten this one. Let's do this one. 101 base 2. We start with 0, 1, and 2. That will give us 1 times 2 raised power 2. This one is 0. I don't need to do that. Plus 1 times 2 raised power 0. So that will give us this one here 4 plus this one here 1. So that will give you 5. So I'll carry out my division. 105 divided by 5. That will give me 21. That will give me 21. 21 times 5. 5 here, 10, you write 1, yes, 21. So 21 now, I will divide it. Oh, where am I going to do that? Okay, let me clean this one so that I can be able to do it here. I wanted to see the two methods side by side and see which one you would prefer. But the board is not enough. So I'm going to clean this one so that we can do it here. Okay, 21 in 2, that will give us 10, remainder 1. 2 again, that will give us 5, remainder 0. 2 again, that will give us 2, remainder 1. 2 again, that will give us 1 remainder 0. 2 again, that will give us 0 remainder 1. So when you take it from down, that will give you 1 0 1 0 1 in base 2. Okay, which is the same thing we got in the other method. Okay, so the choice is yours if you're going to use this method or if you're going to use the other method. Let's solve another example. I'll also try to see if I can use the two methods to solve that and see how our answer will look like. Okay, so let me first of all do the other method that I like doing, that I'm sure that my answer is correct. So let's do that. I have 5, 5, 0 base 7, 0, 1, 2. That'll give us 5 times 7 raised to power 2 plus 5 times 7 raised to power 1 plus, that one is 0. I don't need to do it. So that will give you 5 times 49 plus 5 times 7. 5 times 49, that will give us 245. 245 plus 5 times 7, that will give us 35. So when you add that, that will give you 0, 8, 2, 280. Okay. Then 20 in base 7, 0, 1, that will give you 2 times 7, 1. This is 0. I don't need to do that. That will give you 14. So 280 divided by 14, that will give you 20. So with this 20 now, you can now come here and convert back to base 7. 7 here, that will give you 2 remainder 6. 7 here, that will give you 0 remainder 2. So what is your answer? Your answer will give you 2, 6 in base 7. So this is the, like I said, is the method that I prefer. Okay. Then if you want to use long division, let's do long division 5, 5, 0, 2, 0. Okay. So here the question is first pick first two digits, which is 5, 5. Okay. 2, 0. How many 2, 0 are you going to get in 5, 5? Remember, you are not doing this in base 10. You're actually doing it in base 7. Okay. So this is another thing you have to remember. But I know that 2 of these will give us 4, 40, which is not up to 7. Okay. So 2, we have 2 of it. So 2 times this will give you 40. So you subtract. This one will give you 5, 0. This one will give you 1. So you now have to add your 0 down. Okay. Now, how many 20 are you going to get in 150? Yes, exactly what I was saying. How many 20 will you get in this? In base 7, how many 20 will you get in 150? Some of you already are saying 7 because 7 times 20 will give you 140. That's actually wrong. In base 7, because we are doing this in base 7. Okay, so you can't get up to 7. If you get up to 7, you can't write 7. You can't write 7 here because if you say it's up to 7, so you can't write 7. So you ask yourself, how many 20 will I get in 150 in base 7? Remember this number. Oh, I said 150 in 150. This number is 150, and this number is 20. It's not like 20 and 150 that we know that 7 times 20 will give us 140. This is 150 in base 7. It's not just 150. So it's not even up to 150 when you convert this number back to base 10. Okay, so let us do that. Now, see, that's the complicating part of it. Okay, so you have to add this number in base 7 till you get 150. Then you now know how many of this number in base 7 will give you what? 150. Let's do that. 20 plus 20. Oh, 20 plus 20, that will give you 40 in base 7. Another 2, that will give you 60. So we have, let me just put mark the ones we are adding. Another 2, 0, that will give us 0. This will give us 1, carry 1. This will give us 110 or 110 in base 7. So we'll take another 2, 0, that will give us 130. So we'll take another 20. That will give us 150. Remember, I did this addition in base 7. So how many do we have? 1, 2, 3, 4, 5, 6. So we have 6. 6 times 20 in base 7. That will give us 150. You subtract, you have 0. So your answer becomes what? 26 in base 7. All right. I'm laughing because when I was saying that it's going to be complicated, some of you might not really understand. And this number is just base 7. If it's base 16 and the number is a little bit large, it's going to really be a problem to solve. But if you don't get this method, please, I will advise you to stick with this method. Okay, it's very simple and a little bit more direct. And if you have done number base a lot, doing this expansion to base 10, I don't think it's going to actually be any problem for you. So in the next video, which is where we are going to end division, so I don't want us to spend more time or too much time on problems on division because we have done a lot of arithmetic operation already. So we are going to move to problems in number bases that will lead to algebraic equation. Of course, when we talk about algebraic equation, we are talking about simultaneous equation, linear equation, and quadratic equation. So we can have a quadratic problem that will lead to quadratic equation. We can have a quadratic number-based problem that will lead to linear equation. So do well to check back so that you not miss anything. Very important. So we are going to stop at this point. Thank you so much for your time, and do well to subscribe to our channel, share our video, and please like our video. Give a video a thumbs up. Okay, thank you for your time, and see you in the next class.